Leetcode number 20, the valid parenthesis, in which we are given a string and we ought to decide whether the sequence of strings that are given are valid or not. And the valid is defined basically if open brackets, basically we have an open bracket, something like this, basically it should be closed with the same type, and the order matters. For example, I'm going to use my whiteboard here. For example, if this is an opening, we have the closing corresponding to that opening. Therefore, it's a valid string. Similarly here, if we open, right, and we open again, what we have is, and then we close, right, what we can do is that we basically cancel each other. These two cancel each other. And we are ended up with basically this character, the opening, and we have the same type for closing here. So we end up, after canceling these two, we end up with zero string. Zero, like empty string basically, and this is valid. Similarly here, we open, right, and we get here, right, we close, so we cancel out. We open again and we close, so it's valid. So these three examples were valid example. However, so I'm going to keep that in the screen. For this example, let me change color. Just we open here, but we close with a different type, right? They cannot cancel each other. Therefore, it's not valid. Similarly, we open here, we open again, we close. So let me change this color just to be consistent to the valid one. So we open here, we close, so we can cancel out this two. We're good. And just, yeah, we have open already one here, and we close with the same type. But now we get to this one, which we don't have anything. Basically, we don't have any opening corresponding to this one. Therefore, it's not valid, right? And finally, we open here, but the closing is not, so like the closing here is not the same type as the opening that the closest opening, right? So we cannot cancel these two, therefore not valid. You get the idea. And the procedure we are going to follow is basically whenever we have an opening, right? Whenever we have an opening, we add it to a stack. Let's say we have a stack, we add this character to the stack, right? So basically our stack looks like this. And let's say we have this one opening again, we add that one to the stack as well. And then we have a closing at the same time. We don't add the closing one to the stack. What we do is that when we get to a closing, we see whether the previous opening, like the immediate previous opening basically is the same. If this is the same time, we cancel out. Basically, we get rid of this one from our stack, and our stack looks something like this now. And so now, if we are at the end of the string, so this is our string, we don't have anything else, this is not a valid one, right? Because the length of the stack is not 0. However, if we had something like this here, then we would pop this one from the stack as well, so our stack would be an empty array, right? In this case, we would say we have a valid. So this is the procedure we are gonna follow. I'm not gonna basically write code from scratch. I'm gonna just paste my code here. I guess it's just a waste of time to rewrite it again. So we define this stack here. It's last in first out data structure in which the last element is added is going to be the first one to pop out. And we define this dictionary. The keys of the dictionary are the opening bracket, and the values of the dictionary are the closing brackets. And we're going to use them later on to just make sure that we can pop up in a correct way. Then we traverse over the array for each character in, string. For each character in the string, we see if it's an opening string, as we talked about, we add it to the stack, right? If we have an opening, we add it to the stack. But the other case would be if it's not opening, meaning that it's closing. In this case, we have two options. It's whether we have a stack, right? And the last element of a stack is something whose key, like basically the last element of stack is something whose value is si, right? For example, if stack looks like, let's say something like this, because remember we just add the openings to stack, right? If the last stack looks like this, and si, right, is this one, basically si equals to the value of the last element of basically stack, right? Si is this one, last element is this one, whose value is this one, right? So we get rid of this last element here, right? This is our stack after this operation. But if this is not the case, there are two basically possibilities, right? It's either stack is empty, or this basically equation does not hold. In either of the cases, we return false. We keep doing this until we traverse the array fully, and if at the end of the traverse our stack is empty, meaning that we were able to pop out everything with the correct closing, and we return true. However, if a stack doesn't have the length of 0 and the length is non-zero, then we return false. That's it. Pretty simple, huh? And yeah, let me know if you have any comment or question or something. I would be happy to answer that. Thanks. The code, this is the same code as you've seen a couple of seconds ago. So yeah, it should work. It should be very fast. Yeah. So in terms of complexity, as you may see, the time complexity is on. We are traversing LA. We are doing some stuff in between, but that doesn't really matter. And in terms of space complexity, we are having a stack, right? We can add a lot of elements to stack. So in the worst case, it could be on as well, right? Bye.